All right, let the fun continue. Systems of equations, again, but this time it's a circle and a line. So, same basic idea as a parallel, or as a parabola. I don't know where that came from. It could have two solutions. You know what I'm trying to say. So, two solutions. It could have one solution, or it could have no solution, no real. And the same basic things occur. This is technically one solution with a multiplicity of 2. And no real means it's either imaginary or complex. Imaginary just means it's there's an I, and complex means that there's a real number and an I. So remember our standard form of a circle and our general form. So you're going to see them in these two ways. But the basic idea is, and the steps are right there, over here, solve the linear equation for a variable, so either x or y, whatever is easier. Substitute it back in. Notice we're using substitution almost constantly. Solve and get your points, so you're going to have to plug it back in. So in this case, to me, x seems easier to solve for here if I just add y. So y plus 6. So x equals y plus 6 this time. So x is this. So I'm going to replace that spot. So I only want one variable. You got to always have one variable in the end. So it's y plus 6 squared plus y squared equals 26. Okay, so now we just solve this. Take a second and multiply that stuff out. All right, so I just multiplied this and put it back into standard form. Remember here, you square a binomial, you got to do the box thing, or however you multiply it through, you wind up getting this. Everything has to go to the side with the y squared. So we wind up getting this. I'm going to divide everything by 2, or factor out a 2 if that's what you prefer. And we're left with y squared plus 6y plus 5 equals 0. And we factor y plus 5, y plus 1. So we get y equals negative 5 and y equals negative 1. So remember, these are our y values. So they go there. Plug it back in to your equation. I know everyone always said always use the original, but if you're going to make a mistake on the original, you're going to make a mistake on the work. So I don't know. I don't see the big deal, but that's just me. So I'm going to plug in a 5, and I get a 1, a negative 5, excuse me, and I get a 1, and then I'm going to plug in the negative 1, and I get 5. So there we go. So much fun. Okay, so these are two more possibilities of different things that you're going to see. You just got to be careful. It's really just math, and you just got to math it out and make sure you're following the right work. So with this one, we want to take the linear and solve it. This one doesn't really matter what you do if you solve for x or y. I prefer solving for y if I can. I have no idea why, I just do. Okay, so I'm going to subtract x and solve for y. But again, it really doesn't matter. So that's negative x plus 5. I'm going to take negative x plus 5 and plug it in for where the y is. So this whole mess is going right here. All right, so just be careful and follow your math, and that's really all it takes. I'm going to step through the first couple steps here. So it's negative x plus 5 minus 3 squared equals 53. That's a whole mess. You just have to combine your like terms here. If you want, you can square these right away. I'm just not going to. Okay, so then this would be negative x plus 2 or 2 minus x. However you feel more comfortable writing it. It doesn't really matter. You have to square it, combine like terms, and do all your mess. I'm going to do that in the privacy of my own mistakes and we'll come back and look. Okay, for a quick recap, so what we have here is we squared these two. When you square them, they're binomials, so you have to write them out twice, do the box method or whatever. And you should get x squared plus 6x plus 9, and 4 minus 4x plus x squared, or, you know, the x squared could, whatever. So, you know, it doesn't matter the order you have those in. Okay, equals 53. Combine your like terms, move your 53 over. You should get this. I divided or factored out a 2. I'm left with x squared plus x minus 20. And then said it's equal to 0, so I factor t-chart, and I get my two x values. Just remember, even though you just did all that work, you're not done. This is my ta-da method, I like to say. Ta-da means 2 answers done always. You say, ta-da, I'm done, and then you're like, no, I'm not. So, you know, it's up to you how you think about it, but you have to plug it back in to figure out what the other side is. So I got y equals negative x plus 5. So y equals negative 5. So that would be 10. And then I plug in a 4, and I should get 1. I ran out of room here, but you just plug in 4 into that mess. Negative 4 plus 5 is 1. If I'm wrong, I'm sure you'll tell me. Okay, and then this last one is just, we'll just start it, and I'll put the answer up. But for this particular one, you just have to see, you got to solve for y first. So y minus x equals 7. So I'll say add x. So y equals x plus 7. Now, everywhere there's a y, you have to put x plus 7. And this is what makes this one super fun. Now, you could almost put this guy in standard form like the above one, using completing the square, but I'm not going to. So we have x squared minus 4x plus y squared, and y is x plus 7 now, minus 6y, which is x plus 7. Now this is just math. Okay, so that was the hard part. This is y equals, y is here and here, so it goes in those two spots. Make sure you double distribute and multiply the negative 6 through, combine like terms, and we'll see in a second. Okay, so here it is, if you need to pause to take a look at it. I got negative 4, 3, and 2, 9 is my solution. Just a lot of math happening here. You know, take a look at it. I double distributed this. I got that. I distributed the negative 6 through, so I got negative 6x minus 42. So those are the two places that you might want to see a mistake. I hope I didn't, because you know me, but there's 3 x's here, negative 4, 14, and negative 6, and I got a 4. And then, you know, move the 23 over, factor that, and plug back in to get your y values. All right, have a good day.